Imagine water like a crowd of tiny magnets. Each molecule's got a positive side and a negative side, and they love hanging out with anything that has charges they can grab onto. Now, bring in glucose. It's basically a sugar cube covered in little handles called hydroxyl groups, those OH pairs. Those act like mini magnets too. When glucose hits water, the positive side of water hugs the oxygen and the negative side hugs the hydrogen. Boom! Hydrogen bonds. Water swarms. The glucose peels it apart piece by piece and keeps each molecule surrounded so it stays dissolved. But oil? Oil shows up to the magnet party wearing a Teflon suit. It's long chains of carbon and hydrogen that share electrons evenly. No positive or negative ends. That means water has nothing to grab. Instead of wasting energy trying to stick to oil, water sticks to itself. Oil sticks to oil. They split like two clicks, forming their own circles. This is the whole like dissolves like rule. Polar dissolves polar. Nonpolar dissolves nonpolar. Glucose is polar with all those OH handles, so it vanishes into water. Oils are nonpolar and smooth, so they beat up and float. If you've ever mixed salad dressing, you've seen it. Shake it hard, you make tiny droplets but stop, and the forces regroup. Water with water, oil with oil. Unless you add an emulsifier, a double-agent molecule with a water-loving head and oil-loving tail, the two won't stay together. So why does water pick glucose and ghost oil? Because water's polarity lets it form hydrogen bond friendships with molecules that offer charged handles. And ignore the ones that don't. Tiny magnets, perfect matches, clean separation. That's the whole trick.